Hey guys, in this video we are going to talk about the Pythagorean Theorem, and we're going to have two examples. Hopefully after these two examples you will be a Pythagorean Theorem guru and you will be able to answer every Pythagorean Theorem question that exists. Here we go. So before we get started with the two examples, I want to take some time and I want to explain to you what the Pythagorean Theorem says and how it applies to triangles. You can only use the Pythagorean Theorem with right triangles. If you do not have a right triangle, you cannot use Pythagorean Theorem. You cannot assume it's a right triangle. You cannot say, it looks like it's a right triangle. They have to tell you, guys, we're dealing with the right triangle. How will they tell you that you're dealing with a right triangle? They'll give you little squares and at least one angle in one corner of the triangle. This square means 90-degree angle. A 90-degree angle is called a right angle. A right angle has to be present in a right triangle. If you don't see a right angle, it is not a right triangle. Doesn't matter how it looks. So, whenever you locate your right angle, your 90-degree angle, your square, just go directly across from it and label that side your hypotenuse. Hypotenuse is what it's pronounced, but it's kind of spelled hypotenuse. So that's what I say in order to spell it correctly. From there, it doesn't matter what you label these. These are called your legs. When you're actually using Pythagorean Theorem, your hypotenuse is always C. Always. And your legs, it doesn't matter. You can put A, you can put B, you can put A here, and you can put B. It doesn't matter which one's A or B, but you have to make your hypotenuse C. I'm going to put this as B, and this is A, just because I want to. So, let's go to this triangle here. First off, can we use the Pythagorean Theorem with it? Yes. Why? How do I know that? I have a right angle. That right angle makes me happy. So now that I have a right angle, the first thing I do after I locate my right angle is look right across from it and label this side my hypotenuse. My hypotenuse is always labeled with the letter C. It doesn't matter which one's A, which one's B. A, B. Label this one before I do it. So pause the video, label it correctly. Make sure you put a smiley face by your right angle, because that lets you know you can use the Pythagorean Theorem. And then label your hypotenuse as C. Label your other legs A, B. Doesn't matter which one. Okay. You should have put a smiley face right here. And right across from your smiley face, you should have put C, because that is your hypotenuse. And then you should have put, it doesn't matter, A or B. I'm going to put B here and A here because I want to. It does not matter. So if you put A here and B here, you're still correct as long as you had C here and a smiley face right there. Alright, so now that you know when you can use the Pythagorean Theorem, whenever you have a right triangle, and you have a right triangle whenever you have a right angle, and you have a right angle whenever they tell you this is 90 degrees or they give you a square, and now that you know where to label your C, which is always at your hypotenuse, you're ready to try a problem. Here we go. A baseball diamond has 4 right angles and 4 equal sides. Each side is 90 feet. What is the shortest distance between home plate and second base? Round your answer to the nearest tenth. Okay, so they're talking about a baseball diamond. You always draw a picture first. So what I'm going to do is draw a picture. They talked about a baseball diamond that has 4 right angles and 4 equal sides. So I'm going to draw a diamond. And when I draw my diamond, I'm going to try to make them so that I have right angles. That diamond is looking kind of excited, if that's a good word to describe it. It's not really looking very strict. But anyways, so I have my diamond. I am then going to say, okay, ooh, they said each side is 90 feet. That's important information. So that means that this side here is 90 feet. This side here is 90 feet. This side here is 90 feet. This side here, 90 feet. Alright, now it asks me what is the shortest distance from, oh, let me label my bases. This right here is home. First, second, third, and hopefully my players will make it back home, win the game. Alright, so now it's saying, what is the shortest distance from home plate to second base? They want to know this distance right here. Alright. Ooh. I see right triangles. I see, if I was to separate my picture, I see this shape right here, which is a right triangle, and I see this shape right here, which is a right triangle. And on either shape, it doesn't matter. I just need to pick one. Any one right triangle I can use my Pythagorean theorem with. I see that this is labeled 90 feet. This is labeled 90 feet. And they're asking me for the distance from home plate to second. This is what they're asking me for. So I'm going to put an X right here, because that's what I don't know. I don't know this distance. Alright, so now that I know, I'm going to erase this one because I don't really care about it. I was just showing you guys the shapes that I see. Now that I know what I'm looking for, I am going to do what Miss Frazier just told me to do. Put a smiley face at my right angle. After I have my smiley face, right across from it, I'm going to put C. That's my hypotenuse. And then I'm going to put A here, B here. It does not matter. I could put A here or B here. Wouldn't make a difference either way. Now that I have labeled my picture, I can go ahead and start doing the math. Pythagorean theorem is a squared plus b squared equals c squared. 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 So now that I have a squared plus b squared equals c squared, I can substitute in what I know. Ooh, so instead of a, I can erase it, and instead of a, I can put what a is. A is 90, because that's what I labeled it to be. Instead of b, I can put what b is. B is also 90. And c is x. Okay, I can definitely do this. I have an equation. I only have one unknown. I can solve for x. I know how to do that. Alright, so when I'm solving for x, first thing I'm going to do is find out what 90 squared is. So 90 squared is 9 times 9 is 81, and then I have 2 zeros, plus another 90 squared, so plus another 81 with 2 zeros, equals x squared. Put this together. 81 plus 81 is 162. 2 zeros. Alright. From here, I have to get x by itself. So I'm done simplifying. I just need to get x by itself. In order to get rid of a square, I have to take the square root of both sides. Because if I take the square root of both sides, a square and a square root cancels each other out. So now I don't have a square anymore. I'm left with x over here. X equals plus or minus the square root of 16200. Alright, I can put that in my calculator. So I'm going to go to my handy dandy calculator. I'm going to put second x squared. That'll give me the square root symbol. And I'm going to put 16200. I'm going to hit enter. And it tells me x is approximately, I'm going to write all of the numbers down. Notice I put a little squiggly equal sign because it does not equal that. It's about that. They rounded it. So what is x? They told me to round it to the nearest tenth. This right here is, this is my tenths. So I have to look here, and this will tell me what to do to my tenths place. It's a 7. 7 means my tenths place need to go up. My answer is x is about 127 and 3/10, because that 2 had to go up because that 7 is 5 or higher. Okay, not too bad. Answer it in a complete sentence because my teacher just loves when I do that. It said, what is the shortest distance between home plate and second base? My answer is the shortest distance between home base, no, home plate. That's exactly what it says. I'm just basically rewriting my question. Between home plate and second base is about, I can't say is period because that means it's equal. It's not equal. I rounded. The calculator rounded. Is about 127 and 3/10. What units am I talking about in my problem? Feet. Feet. Got my answer. Not too bad. Not too bad. Now, the last example. And after this example, I am hoping that you will be extremely comfortable with the Pythagorean Theorem. My last example is this. They want me to solve for x. Pretty straightforward. It's not a word problem. It's saying, bam, just do the math. Alright. So, I'm looking at my picture. Ooh. I see a right angle right here. I'm getting excited. This looks like a right angle. I might be able to use this. Oh, no. Wait, I can't use this triangle. My teacher just told me that I can't assume it's a right angle. I can't say it looks like a right angle. It has to explicitly tell me it's a right angle. So when I'm looking at my picture, I am only looking at the triangle that actually told me it's a right angle. So I'm going to use this triangle here because it's the only one I know for sure is a right angle. Alright, so looking at this, I'm going to put a smelly face right here at my right angle. And right across from it, I'm going to put C for my hypotenuse. And now I'm going to put A here, I'm going to put B here. It does not matter where I put A, where I put B. I just make sure that I have my C across from my happy face, from my right angle. Okay, time to do some math. My Pythagorean Theorem is A squared plus B squared equals C squared. My Pythagorean Theorem, A squared plus B squared equals C squared. A squared plus B squared equals C squared. Now, I have to substitute in my information. A is 8. So I'm going to erase A. And instead of A, I'm going to put 8. B is X. So instead of B, I'm going to put X. C is 17. So instead of C, I'm going to put 17. Okay, time to do some math. 8 squared, 64, plus X squared is X squared. 17 squared is, let me think, 289. Okay, gotta solve for X. Gotta get X by itself. Is X by itself? Nope. It's not on this. It's not by itself on the side of the equal sign. So I'm gonna minus 64 from both sides. When I minus 64 from both sides, I'm left with X squared equals 289 minus 64, 225. Okay. So, do I have X by itself? No, I do not. I have a squared there. How do I get rid of a square? It looks almost identical now to the last step in my previous problem. Square root both sides. When I square root both sides, the square and the square root cancel each other out. I'm left with X equals the square root of 225 is positive or negative 15. Okay. I mean, I'm always going to have a positive length. X represents the length. Just like in my previous example, you notice that right here, after I figured out what the square root is, I just made it positive because I can't have a negative distance from home plate to second base. So whenever I'm talking about length, I'm going to just make sure I know to make it positive. So yes, X equals plus or minus 15. Oh, that's my answer. X is 15. Beautiful, beautiful math. I hope this video helped you. I hope you do not have any more questions. If you do have questions, comment, text me, just let me know, and I will try my hardest to answer your questions and definitely clarify any misunderstanding. I hope you are now a Pythagorean Theorem wizard. You're going to go around talking about Pythagorean theorems. You're going to go around the world and look at things like, I can figure out this distance using Pythagorean Theorem. This looks like a right triangle situation. Ooh, I would just love if you guys came back and told me some real world triangle problems using Pythagorean Theorem. Have a great day and toodles.